1 to 4, no? It is 1 to 4. If there's an open circuit, any current will flow through this? Any current will flow 1 to 4? Nothing, no? So what happened to power across 1, 2, 3, 4 will be 0 because there's an open circuit is there. So you have to be careful. Huh? So whenever a bulb, it is fused, what happens? Replace the bulb with open circuit and check again what will happen to the other bulbs. They may test you with questions like this. Now suppose if a bulb 4 fuses, what will happen? The 1, 2 will glow. 1, 2, 3 will glow. Again, you have to check the 1, 2, 3. What is the power across it? Again, will they be safe or not? So what happens is, if one bulb fuses, what happens? It may damage. If one bulb damages, it may damage the other bulbs also. It can happen. So they may ask you problems of this kind. Here, what happened? If the bulb 3 got damaged, but at the same time, what happened? The bulbs, remaining bulbs are safe because the main branch current itself is 0, no? So sometimes what happens is, if bulb 2 fuses, then because of that, what happens? The 1, 4 also will get damaged. Can be asked for you question. So what you should do, after any bulb get damaged, replace with open circuit. Then calculate current in remaining bulbs. And they calculate the power. If the power is again greater than the maximum power dissipated, again the bulb will get damaged. So now what we can say, 1, 2, 4 are safe. 1 bulbs. Even I think 4 also will be 100 watt. No, it has come near to just greater than this 100 watt. Even the bulb 4 also will fuse here. So bulb 1, 2, and 4 are safe. Just equal to 100 watt, no problem. Equal to power rating, no problem. Just greater than that, it will burn out. Fine. Okay, these are the any of possibility of questions can be asked here. Okay, now he's asking some. Okay, come for question 21. Something number is given. Bulb C is of very high wattage bulb. So with switch what happens to the brightness switch S is closed to connect a third bulb C? What happens to the brightness of bulb A when C is having high wattage and C is having low wattage? So as they are having same voltage rating, the first case we'll discuss. The first case. I'll close the switch and here the bulb comes. These two are identical. These two are identical. So let me call them as resistance R. What about the resistance of C? No, C is having very high wattage. Very high wattage in the sense, then what should be the resistance? All are having same voltage. So if power rating is more, high wattage bulb, P equal to V square by R. PC equal to, we'll take like this, PC equal to 12 square by RC. If PC is very large, then what will happen to RC? RC will be very small. Anything will happen to the brightness of the bulb with the switch open, with switch closed. That's what it's telling. So first, I think we should have a here. What is the like a current will flow only here. So let's call I naught. It will have some wattage. So let me call that as P naught and P naught. Both will have same power initially with switch S open. I'm asking you to come to the problem. With switch S open, a current I naught will flow only through this branch. Look at this, the current I naught will flow only through this branch. No, so both will have same intensity. The brightness of both bulb A and B will same. So after closing switch, tell me what should happen to brightness of the, you have to compare with P naught. So here let it be PA. This is PB. Anything can you say about the current? Same current will flow or less current? This is now resistance is R, no? So what you can say RC. RC will be very much less than R. So this will become like a shorted, no? Short circuit wire. So what all the current that is generated? So this current will flow through this bulb only. It is as good as shorted. The bulb is shorted. The bulb will be shorted here. So now come for this one. So what will happen to you compare I naught and I? You compare I. So what is I naught from this diagram? I naught should be V by 2R, no? What about I? Only V by R. V by R plus RC. As RC is very much less than R, is equal to only V by R. So what do you expect current will increase, no? So what happened to intensity of bulb will be more. So PA greater than P naught. What happens to brightness of the bulb A? So shall I say brightness of bulb A increases? What is the bulb B? Bulb B is shorted. Bulb B is shorted, so no current through it. So what is the PB? PB will be 0 as no current through it. Now similarly come for bulb C is of very low wattage bulb. Very low wattage means PC very small. Then RC will be very large. RC very large. Now what to replace here? No, I will post this. Come for this. Let's come for the second case of the problem. In the second case, bulb C is of very low wattage. So PC equal to 12 square by RC. As PC very small, RC very large. Very large means what I should do with RC very small means equal to one wire itself. RC very large means open circuit. So where all bulb C is there, I should put open circuit. So this you should write it as short circuit in place of bulb C. Here open circuit should come. So open circuit means switch is closed. Then in place of bulb C, you put open circuit because RC very large equal to infinity. Then what all the current? Current will flow like this only. And now you compare the intensity of bulb A and B. Will be similar to that one. No? So PA equal to PB equal to P naught. So what will happen to intensity of bulb A will not change. Intensity of brightness of bulb A will not change or remain same. Anything questions can be like this. They'll make you to analyze a situation. Okay, fine. I'll proceed down. So this, okay, no, low resistance bulb almost equal to short circuit. RC very small or RC equal to 0. Because of that, I'm asking you to replace with a short circuit. Here, open circuit. I think